Number 1. Points A, F, and E are collinear. Oh my goodness, I slept last night. And I forgot what collinear meant. What does collinear mean? What? It goes through all the points, okay. Collinear. So co means same, and linear kind of means, say it louder, line. Very good. So are these points on the same line? Like you were saying, could I draw a line through those points? So A, F, E. Could I draw a straight line that goes through A, F, and E? It would bend. See how it bends here? Right here it bends. So the first one is false. Number 2, points B, C, and D are non-collinear. B is right here, C, and D. Could you draw a line through those?
No.
No, you cannot. So are they non-collinear? True. Totally true. How you doing so far? Did you get those right? A, D, and C are coplanar. Ooh, this one's a tricky one. Because we're going to learn more about that today, but this is an insight to that. A, D, and C, are they coplanar? They're all touching the iPad, aren't they? This one's on the iPad, this one's on the iPad, it's actually on both planes, and this one's on the iPad. If they're all on the iPad, then they're coplanar. They're all in the same plane. So that one is true. It is warm in here. Cool. Points B, D, and G are coplanar. So that's right here. B, D, and G. Are those all in the same plane? You might have put false, but the answer is actually true, and we'll talk about why it's true in our lesson today. Okay? Hi, welcome. All right. How about you have a seat right there, and I'll get your stuff in just a minute. Okay? Chris. Okay. So I'm just going to tell you that it's true, and you're not going to believe me until we do our lesson today. Okay? Points F, E, D, and A are non-coplanar. F, E, D, and A. That one is actually true. Those are not coplanar. 3 of those are kind of in like the keyboard, and then A is way up there in the iPad. So it was false, and then the rest were true. False, true, 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 true. All right.
I thought we were going to talk about it before.
So these are the answers to the point line plane homework. Yeah. What? AG for part B. Yep, GA is the same as AG. So notice on number 1, part B, the order doesn't matter because when you're naming a line, you can reverse the order of those letters and it's still the same line. Circle the ones that they get wrong. You can. You're going to do too, yeah. Well, both of you going to do it wrong. Hey, can you grade Alex's real quick? So going over the homework on 5B, I want you to think of collinear means I could put a line through it. Collinear, I could put a straight line through it. So if you look at E, C, and D, these points are not in a row. They're not in a connected straight path. They kind of form a triangle, don't they? You see how I could connect them and form a triangle? They're not collinear because they're not in a row. I could not put one line and catch all 3 of those. I just couldn't. So that's why that one is false. Give me another one. This is so exciting. A and C are collinear. Could you, on your paper, draw a straight line through point A and point C? Totally could. Just because the line isn't drawn doesn't mean it doesn't exist, and we learned that yesterday in class. Remember with our whiteboards, we totally did that in class. So that's why that one is true. They are collinear because they are in a straight path. I can connect them. I can. What else from the worksheet that you got wrong? Did you get any wrong? That you're wondering why? Yeah. 5D. B, C, D, and E are coplanar. So, B, C, D. Okay, all 3 of those points are in this plane right here. But notice E is up above that plane. It's like there's a line shooting through the plane, and E is way up here. Is E in the same plane as B, C, and D?
Yes.
Well, it's kind of a trick question. And the reason that it's a trick question is because B, C, and D are in a row, and we're going to learn about that today. Could I draw a plane and catch all three of these and kind of catch point E? And I could, because they're in a row, and so I could draw my own plane. And I could catch all of them. Now, if they weren't in a row, if these weren't in a row, the answer would have been false. But because these are in a row, the answer is true, because you could pivot. Oh, I have another paper. I know it's confusing. You could take, okay, here's the points, ready? Dot, dot, dot. I could take a plane, I could hit all those points, and I could also hit point E. So I could grab all of them with one plane without bending. And that's why that one is true. But I promise we'll talk about it more in the lesson today. Talk about notation. Notation just means that you're writing things correctly. Like in English, there's a certain way that you write things, right? Like you put a subject and then a verb, like there's a certain order. Same with geometry. There's a certain way that you write things. So raise your hand if you can remember how you're supposed to name a point. What? Louder. Capital letter. Any capital letter. Name a point off that picture. Okay. Point Z. That's how you name a point, is one capital letter. All right? How do you name a line? Do you know how to name it? Like if I were to name a line from that picture. Actually, no. On your whiteboards, name this line right here, please. On your whiteboard, name that green line. Let's see who knows how to use correct notation. Go grab a whiteboard if you didn't already do it. That is perfect. First one, good job. Show me, hold up. Very good. Very good. You got to put arrows on it. You named a segment, you didn't name a line. Good, good, good. Awesome. So the answer was capital W, capital M with a line on top. Must have arrows. Must have arrows. All right. On your whiteboard, I want you to name this red plane. Name that plane on your whiteboard. You can erase your other one. Name that plane, the red plane. If you need to have your notes out, it tells you how to name a plane. Name this. Maybe shading helps. Oh, on your whiteboard. Do you need me to go get you one? The way you name a plane is by any 3 capital letters you want. Could you use 4? Yes, you could use 4 because on your notes it says 3 or more letters from the plane. So you drew a plane. That's beautiful. But you didn't write the notation of a plane. That's a picture versus, like, y'all are making this too hard. There, I just named the plane. I picked 3 letters, 3 points that were in the plane, and I just wrote down 3 points. Do I put a line on top of this? No, it's not a line, it's a plane. So you pick any 3 capital letters, and you just write them together, squish them together. Don't put a comma. Don't put a comma between them, because you're not listing points, you're naming a plane. Okay, let me give you an easy one. Name this segment on your whiteboard. Purple segment. Name it on your whiteboard. Who's going to be first? You were first. You didn't hold it up, but you were first. Good job. You got it. Very good. Oh, you need one too. Go ahead. Nope. Yours isn't a segment. Good. Good. Not a line. So how do we name a segment? Capital letter, with just a segment on top, no arrows. It's that easy. It's that easy. You name it by its end points. Okay. Name this ray. I'm going to go crazy, guys. I'm going to draw this crazy ray shooting through my picture. Let's start at Z, so I'll erase that. Name that ray that starts at Z. and goes through P. Name that on your whiteboard. First one. The order does matter on this one, so try that one again. Good, good. We're going to have our arrow go this way always. Kind of like we read from left to right, our arrow's going to go from left to right. Good, good. Good, just one arrow though. Where does the ray start? It starts at Z, and then it goes through P. So capital Z, capital P with a ray on top. On this one, order doesn't matter. Order doesn't matter. Order doesn't matter. The only time the order matters so far is with a ray. The order does matter. Okay, what's the symbol for congruent? We had it in our warm-up yesterday. It's an equal sign with a tilde or squiggly on top. Yep. So that's the sign for congruent. What's the symbol for parallel? Show me with your arms. Show me. Yep, just like that. Parallel. Ooh, and what was the symbol for perpendicular? A capital letter what?
Upside down.
An upside down capital letter T. Awesome. Okay, one thing I just want to show you is that I just want you to know the difference between this and this. It seems like such a silly thing. You're like, those aren't any different. They both say MT. But we are going to be kind of picky about it. This right here is segment MT. It's an object. It's a segment. This right here means I want to know the distance from M to T, like 5 inches. So this one is a segment, like a symbol, and this one is a number. So when you put a segment over it, it's an object, and when you don't put a segment over it, it's a number. It's a numerical value. Okay? That's really all I want to say about that one. This is fun. All right, I'm going to call on people, and I want you to be translators. You're not going to translate from, like, English to Spanish. You're going to translate from math language to English. Okay? Oh, this is small. Okay. Let's start with Alejandro. If someone was asking what this meant, what would you tell them it means? Just name it. Say it out loud. No, that's this one. But what would you call this? Is that plain MT?
Not a line.
Line MT. See? Cool. All right. Raekwon, what about number 3? We're skipping number 2. What is this? Out loud in English. Say the whole thing.
Ray XY.
Beautiful! That is ray XY. Very good. Alex, number 4.
Is that a segment?
Yeah, keep going. Yes! Segment HV. Very good. Savian, number 5. What? A, but what is it? Point A. Because when you use one capital letter, it is a point. Very good. Trinity, number 6. Line M. That one was kind of tricky. Let's rotate my... But a lowercase italicized letter is actually a line. Very good. Okay, number 7. I won't call him anyone new. That would be mean. Seth, number 7. Can you read this whole sentence?
G8, 9GH,
Perfect! Line GH is parallel to line IJ. That was very good. Richard, number 8.
Segment OK.
Congruent. Beautiful. And Michelle, number 9. Perfect. Very good. Moving on. We got it now. Okay, we are finally to this handy-dandy sheet of paper that you just got. Today, our goal is to learn 4 things. We can learn 4 things, guys. And guess what? We already learned 2 of them yesterday. So we're really only learning 2 things. So that's our whole goal today, is to learn 2 things. Let's go over the ones we learned yesterday. Postulate number 1. A postulate is something in math that's accepted to be true. So we are just accepting that this stuff is true, okay? Yesterday we learned through any 2 points, there is exactly one, what? Yeah, line. So write it down. Through any 2 points, there is exactly, oh no, I'm running out of room, 1 line, period. You need to write it down. That is postulate number 1. Through any 2 points, there is exactly 1 line. Through any 2 points, there is exactly 1 line. It takes 2. It takes 2 points to make a line. That's a song. It takes 2. Anyways, I'll play it for you later. Postulate number 2. If 2 lines intersect, what do you get at their intersection? Do you remember? What? No, we're not doing planes yet. If 2 lines intersect, what do you get? What do they intersect in? A point. Right there is a point. Remember yesterday we talked about they don't have to intersect. They could be parallel. But if they are going to intersect, they only intersect once. They intersect in exactly 1 point. So if 2 lines intersect, they intersect in exactly 1 point. Not 2 points, not 5 points, not infinite points, 1 point. All right, the next 2 we are going to fill in today. That's what we're doing today. Filling in the next 2. We're going to do a little discovery with you and the person. What? Yes, I'm just giving it to, they're going to share and they're going to share. I'm giving it to every other person. I do that on purpose. It's okay. All right, before we use these skewers, the next postulate says, if 2 planes intersect. So, we already agreed that if 2 lines cross, we get a point. But what about if 2 planes cross? What do you get when 2 planes cross? Yeah, very good. Say it louder. A line. So if this yellow plane intersects this blue plane, I get like an edge, right? An edge would be a line. When the ceiling intersects this wall, it intersects it on that seam right there. That's a line. So when 2 planes intersect, you get a line. So that is postulate number 3. If 2 planes intersect, they don't have to intersect, they intersect in exactly 1 line. And I like this picture of the teal one and the yellow one because I think you can really see how the points they have in common is that black line. They have no other points in common. That's their intersection. It's a line. So 2 planes, they can't intersect and you get a point. That doesn't happen. If they're going to intersect at all, you're going to get a line. For sure, hands down. All right, next activity. Did everyone have enough time? Got it? Okay. All right, I want you to take your skewer, and you're kind of sharing with you and the person next to you. I'll give out more. Okay, I want you to try to balance your whiteboard on 1 skewer. Try to balance your whiteboard on 1 skewer. Go. Show me if you can do it. On the tip, not the blunt end. No, balance like balancing. No, on the tip. Like using a point of the skewer. So, you've got your whiteboard and you're trying to balance like this. You're trying to balance this. I hope you can't, because you're not supposed to be able to. Okay. Now try it with 2 skewers. Grab 2 skewers and see if you can balance your whiteboard with 2 skewers. It's kind of hard because that's why I was kind of going to have you work with a partner. If you want to work with the person next to you, they can hold one. They can hold both of them and you could try to balance it. Now, the problem with 2 skewers is that it kind of wants to tilt, right? It wants to fall forward or backwards. Don't you agree? With 2 skewers, it wants to pivot. Now, I need you to use your partner, the person next to you, and I need you to try to balance your whiteboard on 3 skewers. You might have to use all 4 of you, right? Let's try it. Here. I hold one, you hold 2 of them, and he'll balance the board on it. Hold 2 of them with 2 hands. Can he balance it on these? Okay. No, not in a row. That's the key, not in a row. Stop. Okay. Look at that! Everyone look.
Wow.
If you have 3 skewers, you can balance a whiteboard. Couldn't do it with 1, couldn't do it with 2, but yes, we could do it with 3. So the reason is that when you had 1, that plane, there were a million planes that go through 1 point. When you had 2 skewers, there's still a million planes that can go through 2 skewers. But when you had 3 skewers made it stable enough to hold the whiteboard. Now, what was happening was Raekwon was trying to put them in a row with me. If we used 3 and we lined them up, would that stabilize our whiteboard? No, it would fall. And that's what that question you were asking from the homework is. That plane is allowed to pivot when you put them in a row. But as soon as you have them not in a row, then that plane is set. It's stuck there. So, this is the 4th and final postulate. Through any 3 non-collinear points, there's exactly 1 plane. Through any 3 non-collinear points, there's exactly 1 plane. It takes 2 points to make a line, and it takes 3 points to make a plane. And why is that word non-collinear there? Because if you put them in a row, if you line them up, it doesn't work. Look at you. Good job. Cool. So, did you ever wonder why a tripod was a tripod and not like a quad pod? Or not like a, I don't know, do pod? So, a tripod has 3 legs because that's the most stable that you can be. So what? We are on source schedule. We sure are. I'm not going to do that. Okay. Complete the sentence with always, sometimes, or never. 2 planes, always, sometimes, or never, intersect in exactly 1 point. Write it on your whiteboard. 2 planes intersect in a point. Good. Try again. Try again. Look at your little cheat sheet. Look at your notes. Good. What do you get when 2 planes intersect? You get a line. So, do you get a point? Never. You never get a point when 2 planes intersect. Because when 2 planes intersect, like this plane and let's say this plane, when this guy, plane number 1, meets up with plane number 2, you get a whole line. You don't get a point. So that one's never. 2 lines are always, sometimes, never parallel if they never intersect. So, 2 lines, they don't intersect. They don't. Are they always, sometimes, or never parallel? Try again. Good. Try again. You might need to look at some things at home. Try again. Good. Try again. Let me phrase it this way. There's 2 lines. They are not going to intersect. What are their choices? They could be what? Parallel Or they could be that weird word that you learned. Skew. They could be parallel or they could be skew. So this was sometimes, because sometimes they're going to be parallel, but sometimes they might be skew. I am going to adjust my lesson because of, I can tell that we're struggling with those always, sometimes, never. Okay. I want you to name the intersection of plane GCB and plane ABC. I'll help you out. I want you to name the intersection of the blue plane and the green plane. Name the intersection. Good, but name it. Yes, perfect, perfect. Superstars, good job. Keep trying. Good, but yes, that'll work actually. Good, but this one won't. This one will work. This one won't work. You can't do like that. You can't. It has to be an italicized letter, and we don't have any of those in that picture. We're not doing parallel right now, but that's beautiful. You had the right answer up there. It's the second one. Good. Where does the blue touch the green, guys? Where? Line CB. If you put segment, I'm not too worried about that. I wouldn't count it wrong if you put segment instead of line, but this is the correct answer. Could I have named it BC? Absolutely yes, because the order doesn't matter. Okay, here's a tough one. Name the intersection of GHA and FED. I'm not going to highlight them this time. GHA and FED. Do you see where GHA is? Because this is the tough one. This is the challenge one. If I connected G to H to A, you're like, wait, those aren't coplanar. Like in the homework problem, those aren't coplanar. But actually, I could put a plane through it. Because it takes 3 points to make a plane. Take a look at this plane. Whoa. Whoa. Planes can shoot diagonally across your figure. So I want to know where that red plane intersects. So this one's easy, FED. I want to know where the red intersects the green. Put it on your whiteboard. Good job. Good job. Good job. Good job. You got it? Capital letters. You got to use capital letters. Good. Good. And you can write the word line. Try again. Or you could be lazy and you could just write capital D, capital A with a line on top. You don't have to write the word line, okay? Okay. You know what? Since it is a SOAR day, I'm going to give you